Hello everyone, today let's solve the problem number 1 to sum, right? So what the question states here, we are given an array of integer nums. You can clearly see here we are given an array of integers nums and an integer target, and we are also given an integer target, right? So we have to return indices of two numbers such that they add up to the target. So what we need to return here, the indices or the index, right? Index of two numbers or indices, right? So just keep this in mind. We have to return indices of two numbers such that they add up to the target. Each input has exactly one solution and the same element cannot be used twice. We have to return the answer in any order. So order of the solution doesn't matter here. We can return the answer in any order. So each input has exactly one solution. They have clearly mentioned. So just keep this in mind. Each input has exactly one solution and the same element cannot be used twice. And the same element cannot be used twice. If you are considering 11, you cannot consider 11 again. And the same element cannot exist twice. So that's what they have given. So this is very important. Each input has exactly one solution and the same element cannot be used twice. So we have to return indices of two elements such that they add up to the target. So such that they add up to the target, right? So let's come to the example 1 here. So let's come to the example 1 here. In this case, so we have been given target 9 here. So we have exactly one solution. Every input has exactly one solution. They have clearly mentioned here on this case. So 2 plus 7 leads to 9. So we shouldn't return the numbers. Instead, we have to return the index that sum up to the target. In this case, that sum up to the target 9, right? So we have to that sum ups to the target in general. So here in this case, 2 plus 7 equals 9, which sum ups to the target 9 basically. So the index of 2 is 0 indexing. So 0 based indexing this is. So 0, this one, the index of 7 is 1 in this case. So this becomes 0 comma 1 here. So we need to return 0 comma 1 in this case. So that is how we got the output 0 comma 1. Here see, because nums of 0 plus nums of 1 is 9. So we need to return 0 comma 1 in this case. So let's come to the example 2 here. Let's come to example 2 here. So we have been given target 6 here. In this case, you can clearly see 1 is 2 plus 4 will sum up to the target 6. Nothing but 2 plus 4 here. This will sum up to the target 6, right? So here in this case, the index of 2 is 1 and the index of 4 is nothing but 2 here. So sorry, yeah. So we need to return this one 1 comma 2 as output. So that's what they have shown here. Same goes with example 3 as well. 6, we have only two numbers. When we add up these two numbers, we will get 6. So in this case, this one, the index of 3 is 0 and the index of 3 is here 1. So we need to return 0 comma 1 as output here, right? So that's what they have shown in the output. So I hope the examples that we discussed is completely clear, right? So I hope the question is completely clear. What we need to do is completely clear as well, right? So first what we will do, let's discuss the approach step by step, followed by edge cases one by one, and then let's write the code and discuss the complexities for the code that we have written. Initially what we will do, let's discuss the approach. So here let's discuss the approach step by step. First thing we have to keep in mind here is we will be going with the hash map approach. So we will be going with the hash map, or we'll be making use of the hash map or one pass approach, right? So we'll be making use of the hash map or one pass approach. So I have considered the same example, the first example that they have given in the question, so that it will be easier to understand. We have already discussed this one. So if we consider the same example for the approach as well, it will be easier to understand, right? So that is the reason I have considered the first example that they have given in the question. So we have already discussed this one. In this case, so this one, the number 2 and the number 7 leads up to the target, nothing but 9 in this case. So we have to return output 0 comma 1. The index of 2 is 0, the index of 7 is 1. So 0 based indexing, this is very important. So this is 0 based indexing, right? So that is the reason this starts from 0 here in this case. So here the output is 0 comma 1, So how we got the output, we have already discussed this one, right? So let's see or let's discuss this one step by step. First step, what we will do, we will store the numbers and their indices while iterating. So while iterating, nothing but we are discussing the initialization part, right? So we will initialize a hash map. So as we have already discussed that we will be making use of the hash map, or we are going with a hash map approach, right? So we will store the numbers and their indices while iterating. So this is important. We will store the numbers and their indices while iterating. Let's move on with the second step here. Iterate over the array. Nothing but we have to iterate over the array elements, right? So we have to iterate over the array elements. First, for the example, this consists of the numbers. Just give me a second here. This consists of number 2, 7, 11, 15, right? So here, let me give 2, 7, 11, 15. So target we have been given 9, right? So at index 0 means 2. The number present at index 0 is 2. So the value is 2. That's what. At index 0, the value is 2. So the required pair is here 9 minus 2. So when we subtract 9 minus 2, the output has to be 7. So here in this case, required pair is 9 minus 2 is 7. We will store 2 in the map. So first 9 minus 2 we have done. So as this is the first step, we will be storing this 2 in the hash map or the map here. So at index 1 we have 7. So for this particular example, we will get the output in the second step itself, right? Or at the second iteration itself. So here at the index 1 we have the value 7, right? At the index 1 we have the value 7. This is 0, this is 1, this is 2, this is 3, right? So let me take some more color. So this one is 0, 1, 2 and 3. At the index 0 we have 2, at index 1 we have 7. This one I'm speaking of 7, right? So in index 1 we have the value 7. Required pair is now 9 minus 7 is 2. So 2. So 2 is already present in the map. We have already stored 2 in the map, right? So here required pair was, we are subtracting the this one first element or the 0th index, the element present in the 0th index from the target element. This became 9 minus 2 equals 7, and 2 is stored as the element that is present is 2 here. We are storing the 2 in the map, right? So 2 is present in the map now. Now we got the 7. 9 minus 2 is 7. So we will go with the 7. Here at the index 1, value 7 is present. So what we will do, we will subtract 9 minus 7 here. This will be 2, right? So we will check whether 2 is present in the hash map or not, or map or not. So if it is present in the map, then we will stop the iteration and we will go with the index, right? So, or we'll move with the next step, we can say. So in this case, 2 is already present in the map in the previous step. So what we will do, we'll move on the next, this one, next step. So the next step here is we will return the indices, or we have to return the indices. So 2 and 7 we got at the index 0 and index 1 here in this case, right? 2 and 7, this one we got at the index 0 and index 1, nothing but the nums array we have. This leads to nums of 0 plus nums of 1, which will lead to the 9, right? So we will return 0, 1 as the output. So the total the final output here is 0, 1. We are not returning the numbers that sum up to the target. We are returning the indices of the numbers that sum up to the target. So we will return 0, 1 in this case, right? So the final output here is 0, 1 we got, right? So this output is same or equivalent to the output that they have mentioned in the approach 0, 1. This output is same or equivalent to output that they have mentioned in the approach. So output we got 0, 1, and this one we got 0, 1 here, where the output that we got is 0, 1, and the output that they have mentioned for the example 1 is also 0, 1. So this is same as the output that they have mentioned for the example one. So the approach works absolutely correct in this case. Absolutely correct in this case, right? So I hope the approach is completely clear. This is the approach that we will be going with, right? So now let's quickly discuss the edge cases, right? So the first edge case here, just give me a second here, 1 minute. So here in this case, the first edge case that we'll be going with here is negative numbers. So negative numbers means all the negative numbers we have considered right here. -1, -2, -3, -1, target is here -8. So this one here, the index, 0 based index, this one is 0, 1, 2, 3, 4. You can clearly see here the index 2 and the index 4 will sum up to the -8, nothing but -3 plus of -5, nothing but here -8. So index, the numbers -3 and -5, when we sum up this one, this will lead to the target -8. So we need to return the indices. This will be 2 and 4 in this case. So the output is 2, 4 in this case. Fine. So let's move on with the second edge case here, duplicates in the array. So we have duplicates here, same number 3, 3. So we have the duplicate for the element 3 here, that is present in the array. So target we have considered 6 here. 6 means when we sum up, we have only two numbers. When we sum 3 and 3, 3 plus 3 will be the target 6 in this case. So we will return the indices or the index of each element here, 0 and 1 in this case. So the output is 0, 1 here, right? So the output is 0. Let's discuss the final edge case or the third edge case here. In this case, we have the numbers we are considering. We are going with the large numbers, or we are considering the edge case for the large numbers. Nums we have 10,000, 20,000 and 30,000 here. Output we have been given 1, 2 here. The output we have been given 1, 2 here. The output we have been given 1, 2. Again I'm telling 1, 2 how? Here 20,000 plus this one. Actually target, I forgot mentioning, target equals 30,000 here in this case. I forgot mentioning here. This is fine. The output here is 1, 2 because, just give me a second, what happened to this one? Just give me a second here. So the output here is the target we have been given here as 30,000, and when we sum up 20,000 plus 10,000, this will lead to 30,000, right? This will lead to 30,000. So in this case, we have 0 based indexing. We are going with the 0 based index. So 1, 2, we need to return as output 1, 2. That's what. So these are the three edge cases that we need to consider here, right? So these are the three edge cases that we need to consider here. The first one was for the negative numbers, the second one was for duplicates in the array, and the third one was for large numbers. So I hope all the three edge cases are completely clear, right? Now what we will do, as we are familiar with the edge cases and this one approach as well. So as we are familiar with the approach and edge cases, it will be easier to write the code now. Let's start writing the code. Here, first step, what we will do here, in this case, we will create the hash map to store the array values, right? We have already discussed this one, that we will be going with the hash map. So I'll just give here map of integer, integer. This is fine. I'll just take the variable name map and I'll make use of your new hash map. This is fine, right? So the second step here is we will iterate over the array, or we will just iterate over the array, or we will be iterating over the array. So I'll just write this one quickly. So let I equals 0 here, I less than length of the nums here we are considering. So let's increment the I here. So after iterating over the array within the for loop, first step here is we need to find the required complement for the current number. So that's what we discussed. We need to find the required complement for the current number. So how can I articulate this one in the form of code? I can just write here int complement, int because it is of the type integer, int complement here. In this case, this will be target minus nums of I, or iterated value of the nums. This is fine. So the next step here is what we will do. We will check if the complement is already stored in the hash map or not. If it is already stored, then what we will do, we will return true. So in the example, 2 was already present, so 9 minus 7 equals 2 we did in the second step. In the first step, we already considered 2 and 2 was stored in the hash map. If you remember, 9 minus 7 was 2. So if the complement is already stored in the hash map, then what we have to do, we have to return the indices of the complement and current element, right? So that's what we need to do. First, let's check if the complement is already stored in the hash map by making use of the if condition. So here, if I can write in this way, map dot contains key of complement, right? So let me copy this one complement and let me paste it over here. Complement, this is fine, right? So I hope this is clear. So the next step, if it is found, or if found, we have to return indices of the complement and current element, right? So we have to return the indices of complement and the current element. So again, I'm telling, if complement is found, if it is already stored in the hash map, if found, then we have to return the indices of the complement, and we have to return the this one. We have to return the indices of the complement and current element, right? So that's what. So I'll just give here return new int type, right here, this one. So I'll just make use of map dot get to get the value, right? To get the value. So to get the value of complement, right? So let me copy this one again. Let me paste it over here. Complement, comma, index I. So if found, we have to return the indices of the complement. So if found, we have to return the indices of the complement and the current element, right? This is fine. That's what we have written. So the next step is, if the complement is not already stored in the hash map or map, then we have to store the current number and its index in the hash map, right? So if 2 was not already present in the this one, we hash map, then we would have stored 7 in the hash map and went to the next element, and we would have went to the next element, right? So that's what. Otherwise, if the complement is not already stored in the hash map, we have to store the current number and its index in the hash map. For that one, we need to implement the same thing in the form of code here. So this is simple to implement. So here I'll just make use of put. We are storing, right? So this one, nums of I, so this one will be I in this case, right? So final step here is, so we don't have to execute this one as per the problem constraint. So this one, we have one solution, means always one solution exists. That's what they have given in the question. For every this one input, exactly one solution exists. That's what they have given. So what we will do in this case, let's return new int of 0 we can give, or I can go with this one as well. I can just make use of the flower brackets as well, flower braces, right? So this is it for the code, simple to understand, right? So let me hit the run button quickly. So here we have some error in the line number 9, error expected semicolon, where, so this one, this is fine, right? So yeah, let me hit the submit button. I forgot to give the this one, what I call semicolon. See, I should have hit the run button. Wait for let. So symbol class let here. This one, where the line number 5. So yeah, this is Java, right? So I always get confused with the JavaScript. I have solved n number of problems using the JavaScript. So this is Java. So let me give int instead of the let. So let me hit the submit button again. So now you can clearly see I have given submit. I have hit the submit button directly instead of the run button, right? So this works for all the test cases. The code works absolutely correct for all the test cases here. So whatever the code that we have written is completely correct on this case, right? I hope whatever the code that we have written is completely clear as well, right? So now, just give me a second here. Now let's quickly discuss the complexities for the code that we have written, right? First, here the approach that we went with here is hash map, or one pass approach you can call it as well, right? So the approach that we went with here is hash map. So what would be the time complexity here? The time complexity would be here pico of n in this case. So the time complexity here would be pico of n. So when I say pico of n, why it is pico of n here? We are traversing the array exactly once. We know that one, right? We are traversing the array once. You can clearly see here the for loop. We are traversing through the array exactly once, storing and checking values in the hash map in the constant time because 1 per operation, single operation, right? So overall time complexity would be because in this case, now we know the time complexity is because of n. So what is the time space complexity here then? So the overall space complexity here would be because of n as well. So why it is because of n here in this case? So in the worst case, all the n elements are stored in the hash map, right? We have to, in the worst case, we might check for all the numbers that are present in the array, right? So in the worst case, all the n elements are stored in the hash map. So that is the reason the overall space complexity would be big of in this case. So the time complexity and the space complexity, or the overall time complexity and the space complexity for the code that we have written is big of 1 in this case, right? I hope this is clear, and I hope whatever the this one code that we have written is completely clear as well. For now, this is it. Thanks for watching, guys.